Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve these problems using the concepts of limit. So let's start with the first problem. Show using the properties of limits that if limit x approaches 5 for f at x is equal to 3, then limit x approaches 5 for x squared minus 4 over f at x is equal to 7. So for this problem, we'll have to use the quotient property of limit. So the first step is to rewrite this expression. So we'll write it as, so limit x approaches 5. So we'll apply the limit to the numerator and the denominator separately. So that's the quotient property of limit. So we get x squared minus 4 over limit x approaches 5 f at x. Now in the numerator, we will use the difference property or the subtraction property of limit. So we'll apply the limit to x squared and minus 4 individually. So limit x approaches 5 x squared minus limit x approaches 5 4 over. Now in the denominator, we have limit x approaches 5 for f at x, and for this we are given the value as 3. So in the denominator, we replace the expression with 3. Now in the numerator, in the first term, we can use the substitution method, so we can sub in x as 5. So we get 5 squared minus. Now in the second term, there is just a constant 4. There is no x, so it is just equal to 4 over 3. So this is the expression that we have to simplify. First we evaluate the square, which is equal to 25 minus 4 over 3, which is, now we can do the subtraction in the numerator, which is 21 over 3, which is equal to 7. So that means that the given equation is true, that limit x approaches 5 x squared minus 4 over f at x is equal to 7. Now we can work on the second problem. Now in the second problem, if limit x approaches 4 f at x is equal to 3, use the properties of limits to evaluate each limit. So let's start with part A. So in part A, we are given limit x approaches 4 and cube of f at x. So for this expression, we'll have to use the power property of limit. So we'll apply the limit to f at x inside the cube. So we can rewrite the expression as limit x approaches 4 f at x, and the cube goes outside the limit. Now we are given that limit x approaches 4 for f at x is equal to 3. So in the next step, we can replace the expression with 3. So we get 3 cubed, which is equal to 3 times 3 times 3, which is equal to 27. So this should be the final answer for part A. Now we can analyze part B. So in part B, the expression is in the form of a fraction. So we'll use the quotient property of limit. So we'll apply the limit to the numerator and denominator. So we get f at x squared minus x squared over limit x approaches 4 and then f at x plus x. Now we can apply the limit individually to the terms, so we can use the subtraction property in the numerator. So we get limit, so I can do it here. So limit x approaches 4, so f at x squared minus limit x approaches 4, x square over, so limit x approaches 4, f at x. So in the denominator, we can use the addition property, and then plus limit x approaches 4, x. Now in the numerator, in the first term, we can use the power property of limit. So the expression becomes limit x approaches 4, f at x, and the square applies to this whole expression, minus. Now in the second term, we can sub in x as 4. So we can use the substitution method. So we get 4 square over. Now in the denominator, in the first term, we can use the given limit, that limit x approaches 4 for f at x is equal to 3 plus, and now we can just use the substitution method in the second term. So we get 4. Now in the numerator, we can apply the limit value that we are given. So it becomes 3 square minus 4 square over 3 plus 4. Now we can evaluate this as, so 3 square is 9, 4 square is 16. So 9 minus 16 is negative 7 over 7, which is equal to negative 1. So this should be the final answer for part B. Now we can analyze part C. So I'll use a different color for it. So for part C, so we are given an expression in the radical form. So we have to apply the limit to each term inside the radical. So we'll start by writing it as radical and limit x approaches 4 to 3 f at x minus 2x. So this is the first step. Now we'll use the subtraction property of limit. So we'll apply the limit to each term separately. 4, then 3 f at x, and minus limit x approaches 4 to x, and all of it under the square root. Now we can use the constant property for limit. So 3 is a constant, so we can move it to the front of the limit expression. So we can rewrite this as 3 limit x approaches 4 f at x, and we can do the same with the 2. So we get 2, and then limit x approaches 4 x, and all of it under the square root. Now we can apply the limit. So limit x approaches 4 f at x is given as 3 minus 2. Now for the second term, we can use the substitution method. So we can sub in x as 4, and under the square root can simplify to, so 3 times 3 is 9, so we get 9 minus 8, which is equal to square root of 1, which is equal to just 1. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.